Hello everyone, welcome back. In this lesson, we're going to build on what we started in a previous video where we created a synth, right, that could play sounds that had an attack released to them. And what we'll focus on in this video is talking about creating musical notes as opposed to just arbitrary frequencies, right? Right now our synth is just playing random frequencies, and that creates a little bit of an audio mush. So as we're moving towards our generative sequencer, we're going to talk about creating more structured musical notes. What I've done here is I've duplicated the previous sketch, so we're going to use that as a starting point. I encourage you to do the same. And we saw kind of briefly in the previous video, we had a sneak peek at this. When we trigger a note on a synth, we can either provide a frequency, or we can provide the note name. And we briefly played a C4 as an example and just kind of brushed over it. Now, this will be familiar to those of you who've done music before. This is the name of a note on, but if you're new to this, we're going to do a really brief little crash course on some basic kind of terminology and concepts, because we're going to need to understand those in order to apply them to our sequencer we're going to build in the last video. So just to help us do this, I'm using a little program, a free program here called Synthesia. And what it does is it just gives me like a piano that I can play, okay, and to show you some notes. So this is the C4. If you look at it on a piano, obviously every instrument is going to be able to play a C4. It is the name of a note. So the C is the name of the note, and then 4 is the octave. So it represents where the note lies, right? So we see we have a C coming back over and over. So this note here comes back here, just an octave higher, and it comes back there, an octave lower. So this is a C3, a C5, and a C4. Okay? So when I play a C4 in my sketch here, see, this is the same note. Obviously, it sounds different because it's played using our fat sawtooth synth. Okay, so this is nice. So we can play specific notes. We can also, if we want to have random notes, right, we can start to think in terms of arrays of notes. So for instance, we could say, let's create an array here. I'm going to call it notes. And then inside of it, we could put C4. What the next note could be, it's up to us. Maybe we'll throw in an E, right? An E4. Maybe we'll throw in a G, right? A G4. So now we have an array that has 3 possible notes in it. And if we wanted to play a random note every time we trigger a synth, we could simply say random notes, notes being an array. So remember, the same thing we did with color palettes. So we're just getting random notes from this selection here. By the way, these 3 notes together happen to form a C major chord. Okay. So notes have names, starting from, we're going to start from C here. This is usually often where we start. And the next note over is D, E, F, G. Then it goes to A, B, and then it goes back to C, 1 octave higher. So these 7 notes I just played are the C major scale, right? And it's the easiest scale to remember because it's just all the white notes on the piano. So what's a scale? Well, a scale is basically a set of notes that will kind of work together in a harmonic fashion. And from a scale, you can derive chords, right? And so forth. So it's going to be good for us to think about working from scales when we build our generative sequencers, because a musical scale is going to give us a collection of notes that are going to kind of work well together. And there's lots of different flavors of scale. Obviously, C major is the easier one because it starts on the C and it's all the white notes, but there's variations on that. For example, we could do right? That is also a scale in C that is called a C harmonic minor, and it has a few differences, right? Some of the notes have been lowered here using the black notes. So this one, right? Have been lowered using the black notes. So the addition of these two black notes in there just completely changes the flavor. There's still 7 notes in the scale, but it's just a different combination. So we'll come back to this idea of scale. We don't need to know about all the possible scales. In this example, we'll see there's a library we're going to use that has all of that knowledge built in. That's going to allow us to quickly experiment with different possible scales. Other concepts that are important to talk about are the idea of intervals. So intervals is basically the distance between two notes, right? So two notes have a distance between them, and this is measured in what's called a semitone. So one semitone is just going from one note directly to the next note afterwards. So going from the white to the black. So this is going up in semitones, and there are 12 semitones in the octave. Right? So if we go from C to C, we're going to go through, if we visit all the notes, just not just the white notes, the black notes as well, we're going to count 12 semitones. So what that tells us is that the interval for an octave, this is going to be important for us, is 12 semitones. So if we jump from here to here, we have 12 semitones. And if we go from here to a lower octave, we're going down 12 semitones. Okay? And there's like other meaningful intervals. We're not going to go that deep into the music theory today. This is just to talk about some basic vocabulary and concepts. So let's recap. Notes have names, right? And we can take a bunch of notes that belong together. We call that a scale. And obviously there's all kinds of different combinations. And the one we're going to start with is just going to be the C major scale because it's just all the white notes. So that gives us 7 notes. Okay. We could, if we wanted to, just build the C major scale in here. This would be very easy. We would just have to go and put in, because again, it's just all of the, sorry, it would be a D4, followed by an E4, followed by an F, right? And followed by an A. So after G, we go to A, and then we go to B. And then we could either go back to C here, but this would be the 7 notes of the C major scale. And we saw there's like different variations. And did I forget one? No, we got 7. Okay. So there's different variations. And in order to play with these, you either need to know music theory, or if you don't, you can use a very handy library called Tonal. Now, not to get confused with Tone.js, this library here is called Tonal.js, got an L at the end. And the whole purpose of that library is basically to encode elements of music theory in a way that we can manipulate them programmatically. We're not going to dive super deep into this library, but we're going to use it primarily to get access to scales. Okay, so for example, here we can see that with Tonal.js, we can say, give me all the notes for a C major scale, and it's going to return them as an array of notes. And we can also specify the octave, right? So we can use this syntax to explore all kinds of different possible scales. And there are lots of different scale types that we can use. I'll give you some ideas, but you can also research this. You can get pentatonic scales. These are scales that only have just 5 notes in them instead of 7. There's different flavors, major, minor. So there's examples here in the documentation, and it's pretty extensive. Right? You can get Egyptian scales, kind of more like Eastern music type scales. So all of that will change the flavor of your sequences that you get to generate. Okay, so let's let's just install the library. So to do this, just like the other libraries, we are going to copy this script tag here on the Tonal.js website, and we're going to bring it into our sketch in the index page. So somewhere over here. Okay. Note that I kept that GUI in here, even though we're not using it, just in case you want to whip it out and play around with it. So now that we have Tonal installed, instead of generating the notes of the C major scale manually, like I just did, which by the way would work if I click now, I'm just getting random notes from the C major scale. We're going to get Tonal to create that scale for us. So in initialize audio, that's my first step here. I could do this in setup as well, by the way, but we'll just do it here. I'm going to say notes equals tonal.scale.get. And we will say C major dot notes. So let's just remember this syntax here. What this returns is actually a scale object. So the scale object has some other functionality you can do on it to manipulate it. But here we're just going to access the notes attribute, and that happens to be exactly the same array that I had just created manually. And we'll see this still works. Now this is nice because we could switch easily to different flavors of scale. For example, we could explore a C minor scale. So you kind of get like a different feel for it. We can get a pentatonic scale. If I can spell it correctly. There we go. Pentatonic has 5 notes in it. And so forth. And you can specify a different starting point. So this first note here is called the root, and this is where the scale starts. So going back to our piano here, I could create a D major scale, but if I wanted to do that, and it's not as simple as just taking all the white keys, there are some black keys that are going to come into the mix because a scale needs to have a specific set of intervals. That's what defines a scale. So this is where Tonal.js becomes very handy. If I wanted to create D major, I don't need to know the music theory in order to create D major. I can just go say, create this scale for me. And we could open the console here just to see that it works. Let's bring in the developer tools, go on to our blob here, and we could say that our notes, right? This has given us the D major scale, and it threw in the correct black notes in there to get the D major scale. So very, very handy. Okay, so let's go back and stick to C major. Now we have a scale. So the other thing we're going to talk about in this lesson is we're going to talk about the concept of note mapping. And the reason this is important is because we're going to want to be able to create a sequence that's going to be based on a particular scale, right? So going back here to synesthesia, this is the scale that this is giving us, but we want to be able to think of, this scale repeats throughout the keyboard, right? So I can get the same notes in a lower octave. I can get the same notes in a higher octave. And we might want to be able to play with this in our generative sequencer. For example, we might want to get 2 full octaves or 3 full octaves of the C major scale, right? Go from here all the way up to here, or even up to here. Right? So the same set of notes are going to be the same, but their octaves are going to change. So we're going to write a little bit of code that's going to start to think of the notes in the scale as simply just having a number. Okay? So once we have a scale, it doesn't matter what it is, we're going to think of the first note as being number 0, right? Number 1, number 2, number 3, 4, 5, 6, right? And then this is the end of our scale. Now note that this coincides with the index values inside our notes array. Okay? So for instance, if we want it to be not just random here, but a little bit more deliberate, maybe we want to get a note index. We're going to map where I click from left to right. Okay, we're not going to draw a keyboard or anything like that. We'll keep it simple. We're going to map where I click from left to right. This goes from 0 to width. We're going to map it to an index. I'm going to go from 0 to 7, knowing that we are going to round down. Okay? So that's going to give me a number between 0 and 6 in practice. And then we could say notes bracket note index. Okay, so if I click from left to right, you can see I'm kind of moving my way through the 7 notes of the scale. Okay? Not very precise, but this is not important for this example. So the important concept here is that we're going to start to think of our sequences and our patterns in terms of note numbers. So we're going to have an array that's going to represent our scale, right? I'm not using the word scale, by the way, for the variable here because scale is a function in P5.js that changes the scale of the canvas. So I'm using the word notes instead. So we're going to define, okay, we want to have, these are the notes we want to have in our primary scale, these 7 notes, but we want to be able to go beyond or below these octaves. So for example, if we think of this as note 0, right, this would be note -1, okay? Or if we think of this as note 6, the octave up would be note 7, okay? and this would be note 8 and note 9, right? So if we think of it that way, it's going to make mapping things to sequences of notes really easy, and we'll be able to go to lower notes and higher notes just by specifying, thinking of our main scale is going to be 0 to 6, and then if we want to go above that or beyond that, we're just going to use negative or bigger numbers than we have space in our notes array. Okay. So how would we approach doing this? Well, we're going to create a function that's going to do this work for us. It's going to take the input number, and then it's going to figure out which note in the array we want, and then whether or not we need to transpose it down or up an octave depending on the note index we're specifying. So we're going to call this function, we're going to call it mapNote, and let's create it over here. So it's going to work in a bit similar way to the map function, right? We're going to want to take a number in, and what we want to get out of it is going to be a note. So our mapNote function is going to take two parameters. We're going to say, here's a note number I would like to get. And here's an array of notes, just in case down the road we want to reuse this function with different scales, different arrays. We'll create a more reusable function here. And if note numbers, if all note numbers were 0 to 6, we could simply return note number, right? But in practice, we can't do that, because what if we ask for 7? Well, 7 exceeds the size of our array here, so we're going to have to do a little bit of figuring out here which note we want to get if we go higher. So the first thing we're going to do is let's figure out the wraparound here. We're going to use the concept of modulo to figure this out. So if you remember, a modulo is the remainder of a division, and if we use modulo, it allows us to say, okay, this is the length of our array, so we're going to call this is the number of notes we have to play with in our scale. We'll say note.length. I'm going to put it in its own variable to make the code a little clearer. And we're going to figure out, what is the index in this array here that I can return, that as I go higher than the number of variables I have in my array, I want to sort of loop back to the beginning, so that when I get a 7, really I want to go to 0 because that's my C note. Okay. So we're going to say note number modulo num notes. Okay. This is the modulo operator in JavaScript. Just a note here, we'll come back to this operator in a minute because it doesn't actually do a real modulo in JavaScript, and we'll run into some issues with negative numbers, but for now we're going to just use modulo and take it from there. Okay. So what that means is that if we were to say, if we go instead of 0 to 7, if we go 0 to 14 here in our mapping, okay, we are going to get a note using mapNote. We'll say this is the note index we want, the array notes, and then we will play that note over here. And we can even just console log it too, so we can see what we're dealing with. That would be handy. Okay. All right. So here I'm getting a C4, D4, E4, right, A4, and then it wraps around, right? You can see it's going back to the beginning of the array. What we're not getting is, of course, we're not changing the octave just yet, because our array only has the notes C4 to B4, right? So this is going to take us back to the beginning of the array. Now, the next thing we have to figure out is what octave we want that note to be in. So this is, let's go back to map notes here. So figuring out the octave, let's put a comment. We'll see if we need to transpose up or down by some number of octaves. And the way we're going to do this is we're going to say, okay, the octave where we want to be is going to be the note number we are getting, okay, divided by the number of notes that we have. So if the note number exceeds the number of notes we have in our scale, right, we're going to get a 1 here. If we're below, this is going to give us a 0, and if it's smaller, we're going to get a negative number. So this is going to represent how much of an octave we want to add to the note, or how much we want to lower the note as well by a certain octave. Then we're going to calculate the interval. So this is where we're going to use Tonal.js to help us do this. It has an interval feature that allows us to say, if we have a note in hand and we want to calculate an octave, we're going to go back to this idea of semitones. We're going to say an octave, 1 octave times 12, right? This is going to give us the full octave interval that we need to apply, and then we can let Tonal.js do the correct transposition for us, which could be a little difficult to do. It's not just as simple sometimes as changing the number here. So we will just say tonal.note.transpose. We'll take the note that we would have normally gotten. Oh, actually, that would be notes bracket I, and we will transpose that note down by the interval. Sorry, I misspelled here. I meant to write interval. Okay. So the idea here is, first we make sure we stay within the bounds of the array by using modulo. So if we exceed the number of notes we have, we're going to keep wrapping around through the available notes. So that's part one. That's going to give us the correct index we can use. And then part two is we decide, do we need to increase the octave or decrease the octave of the note? And we do the transposition here using the tonal library. It makes that very easy for us. We first say, here's the interval we want. The interval is a full octave. And then tonal.note.transpose, we'll take the note that we have from our original scale, and it will transpose it up and down an octave for us automatically. So very convenient. All right, so let's try it. So now if I click my way to the right, we can see I'm getting higher octaves. Cool. Now the problem lies here if we try to go lower and if we simply rely on modulo. Now I'm going to sort of hand wave over that part a little bit, but just stay with me. So if we said, let's say we wanted to go from, let's say, minus 14 to 14, or minus 7 technically, that would take us to a C3, right? And that would be the C5, and that becomes like the range of notes that we want. If we try to go negative, we're going to run into some issues. Okay? If we try to go lower, we get the C3 eventually, but we're going to end up with some negative numbers, which we don't want here in the index. Okay? The problem is in JavaScript, this is getting a little bit more into the math of it. The modulo operator, if you give it an input number that's negative, it's not going to necessarily return a positive number, whereas in other environment, like a true modulo would keep the number between 0 and number of notes. Okay? So in JavaScript, the remainder is simply, the modulo operator is actually just the remainder of a division. And if one of the sides is negative, the answer is going to be negative. So long story short is, to fix this, we need to create a proper modulo function. And if that doesn't make sense, that's okay. It's not really important for this lesson to, have a really good understanding of how to write a modulo function, but it doesn't exist in the JavaScript language, so we're just going to create our own function. So we're going to write a little function that says, take the actual proper modulo of n and m, so modulo, right? And this would be n and m. And the purpose of that function is that it's never going to return a negative number. It's going to keep cycling between 0 and m. So the code for this, I found doing a little bit of research online. It goes like this. We're going to take first the remainder of n by m, and then we're going to add m to this. And then we take the modulo of that final result. And I'm not going to go into the proof of why this works. Just take my word for it that this is a proper modulo operator. And if we use this instead of the percentage sign, we're going to say note number and number of notes. Now, if we provide a negative input number, it's going to cycle around correctly to notes. So now we can go into lower octaves. Let's make that example even more emphasized. We're going to go from -14 to 21. So now this is going to span 5 octaves, right? So we can go really low, and we can go really high, okay? But we still only have the 7 notes of our scale. Okay? So to go back to our keyboard, right, we still only have these 7 notes. Oops. In our notes array, but using our mapNote function, we're able to say, okay, minus, if the note number is 0, we get this. If the note number is -7, we get this. If it's -14, we get this, right? And if it's 7, we get this. If it's 14, if it's 21, we go all the way up here. So it allows us to create, to generate any notes on this piano thinking of the note number in the scale as opposed to the actual note that it is. Okay? So we can have one scale, and then we can go below or above that range just by thinking of note numbers instead of note names. Okay. All right. So this is going to be very useful because we're going to use that as the foundation for our sequence video. So just to recap here, what we did in this this lesson is we went over some vocabulary. So right now we're getting notes from the C major scale. And again, we can put in different scale names. Those of you who know your music theory, you can experiment with this, or you can do a bit of research to learn about different scale names, and then you can come and try them into this program. So for example, I'm going to use a harmonic minor that I demonstrated earlier. Harmonic minor has that kind of mysterious vibe to it compared to the major scale. That's sort of like the happy scale, right? So different scales have different moods. So we can start with a particular scale, and then we've created the ability for us to navigate that scale using note numbers. And this is what the mapNote function is doing, right? It's going to return a note from our base scale using a note number as the input. Negative numbers will return lower octaves, and positive numbers that exceed the note array length will return higher octaves. So our notes array only has the notes from our scale, the main notes, and then we can go below and above that. All right. Okay, so we're going to leave it at that for this lesson. In the next video, we're going to build on this foundation, and we're going to dive into creating sequences. I'll see you there.